All right, so thanks for joining us. A little bit more practice from day 4 for our module. The graph of y equals g of x is shown. We want to state the solutions for each of these. So if I want to know when my function is equal to 0, my function is equal to 0 at each of those spots, which seems to be when x is equal to -4, when x is equal to 0, or when x is equal to 3. If I'm going to assume rational values between 2 and 4, looks to be halfway, so 3. All right, when is g of x greater than 0, which would mean when is g of x positive? We know that that seems to be when x is less than -4, or when x is between 0 and 3. Right? If we have the graph, it makes our work a little bit easier to determine. When is g of x less than or equal to 0? Well, g of x is going to be less than or equal to 0. It seems to be when I am greater than or equal to -4, less than or equal to 0, as well as when x is greater than or equal to 3. So there are my solutions if I'm looking at the graph. Okay. Here's another function, looks to be some sort of rational function. I seem to have some intersections. Looks to be that I have a graph drawn right over here, and I want to find out, well, when does my function equal 0? My function is equal to 0 at x equals -7, as well as x equaling 3. When is my function greater than or equal to 0? It looks to be over on this side of the graph, right? But as well over on this side of the graph. So it looks to be that I'm greater than or equal to 0 when x is less than or equal to -7, or when x is greater than 5. But I also have kind of this part of the graph as well, which would mean when x is greater than 3, but less than 5. Notice that for this one, at 5, my multiplicity did not change. And because my multiplicity did not change, then my graph did not change positive to negative. And so I know I have a multiplicity of 2 on this vertical asymptote. By chance, this does happen to be the graph of a problem that you did early on in evaluating that had multiplicities that was within one of your examples. So just work through, it's fine. But we can identify that this part of the graph, this part of the graph, and this part of the graph all when I'm greater than or equal to 0. And I'll have 3 intervals. Okay. Last one, we're going to write the equation of a rational function that is tangent to the x-axis at x equals 0 and has a vertical asymptote of x equals 3 with even multiplicity. So if I have an even multiplicity, that means that I have x minus 3 squared in the denominator. Right? And if I'm tangent at x equals 0, that means I have x squared in my numerator. And it doesn't give me anything else, so I could just simply say, hey, that my equation is going to be y equals x squared all over x minus 3 quantity squared. That would be my function, and look to keep it simple. Don't have to make it more complicated than it needs to be. We're not asked to graph it, but we could. It wouldn't be too hard to graph this function. We know that we are going to be tangent to the axis. We know that we're going to have an even multiplicity. So let's see if I can draw this asymptote at x is equal to 3. And I might have a horizontal asymptote. It looks to be that I do have a horizontal asymptote at 1. And so what my graph might look like is a little something like this. All right, so I'm going to bounce at this axis and go upwards, right? Vertical asymptote at 1. And on this side, I might look a little something like that. It is possible that a graph might go down to be below 1. But for this particular function, it looks like we're probably only going to have one value of the function where I'm going to equal 1. And there we have. All right. Like I said, we could solve this to see, hey, when does x squared over x minus 3 quantity squared equal 1? And that would be when x squared is equal to x squared minus 6x plus 9, which would be true if 6x were equal to 9, which then means that it's going to be when x is equal to 3/2, which is the only place, and that seems about right. So there we have our graph, right? We could have asked you to draw the graph, but here we just saying, hey, come up with something, and what do you get? All right. Practice, practice, practice. These take time. They're not easy to do. This is where we're getting into the pre-calculus of things. This is where students, if they've done well in the past, tend to have difficulties. You don't practice, it's going to be hard. Thank you for your time.